Water from thin air. How DripDrop atmospheric water generation becomes the water spine of Citiwerx's smart cities. A strategic narrative. Hello, I'm Charles Cortland Hooper, PhD and Chief Systems Integrator. I'm here to share Huntington York Development Corporation's Citiwerx's smart city's ability to be totally self-sufficient in its water production, treatment, and distribution without drawing down on declining aquifers or being co-located with saltwater, where desalination, problematic as it is the only option at scale. Integration with other core advanced Citiwerx technologies will also be presented. Prologue: The crisis hiding in plain sight. There is a crisis unfolding on this planet that receives a fraction of the attention given to energy, climate, or artificial intelligence, and yet it is more immediately, more personally, and more lethally consequential than any of them. It is the water crisis. And it is already here. A 2015 NASA study, drawing on satellite measurements of underground aquifer depletion, predicted a global megadrought unlike anything experienced in the last 1,000 years. That prediction is no longer a projection. It is a description of current conditions. Aquifers that took tens of thousands of years to fill are being emptied in decades. The Colorado River, which supplies water to 40 million Americans and irrigates 5.5 million acres of farmland, has shrunk to a fraction of its historical flow. Cape Town, South Africa came within weeks of running dry in 2018. Chennai, India's sixth largest city, exhausted all 4 of its major reservoirs in 2019. Bengaluru, the very city where Huntington York Development Corp is breaking ground on its first Citiwerx smart city, has been identified by water security analysts as among the most water-stressed major cities on Earth, drawing down its groundwater at a rate the underlying geology cannot replenish. The consequences of this crisis are not abstract. They are already manifesting as mass migration from water-scarce regions, collapsed agricultural economies, rising food prices, contaminated drinking water sources, infrastructure damage from land subsidence as aquifers empty and the ground above them sinks, and in the most extreme cases, starvation. A NASA study using the Palmer Drought Severity Index projects that without dramatic intervention, the global megadrought will cause catastrophic famine, displacement of hundreds of millions of people, and mortality at a scale not seen since the great famines of the 19th century. And here is the profound irony at the heart of the water crisis. The atmosphere of this planet contains approximately 12.9 trillion tons of water vapor at any given moment. Enough fresh water to supply the entire world's needs many times over. It is everywhere. It is in every breath of air drawn anywhere on Earth. It falls as rain and snow. It rises as evaporation from every ocean, every river, every field. The atmosphere is not running out of water. The problem is not scarcity of water. The problem is the inability to access the water that is already there, floating invisibly above every city, every farm, and every desert on Earth. DripDrop USA was founded to solve that problem. And the technology they have developed, a proprietary 4-part atmospheric water generation system capable of producing millions of gallons of pure, contaminant-free water per day directly from ambient air, has been the missing piece in the Citiwerx smart city ecosystem. Not just a water supply system, a complete water sovereignty solution that transforms every Citiwerx township into a city that never runs dry. The atmosphere holds 12.9 trillion tons of freshwater vapor at this moment. The crisis is not that the water is gone. The crisis is that we have not yet learned how to harvest it where we need it. DripDrop changes that equation permanently. Part 1. The Science of Atmospheric Water Generation. To understand what DripDrop has accomplished, you need to understand what atmospheric water generation is, why it works, and why existing approaches to it have fallen so far short of their potential. The fundamental principle of atmospheric water generation, a WG, as engineers call it, is thermodynamic condensation. It is the same process that forms dew on grass in the early morning, that fogs bathroom mirrors after a hot shower, and that condenses moisture on the outside of a cold glass on a humid day. When air that contains water vapor is cooled below a specific temperature, the dew point, the vapor condenses into liquid water that can be collected, filtered, purified, and consumed. This principle has been understood for millennia. Desert cultures in the Middle East, Chile, and Peru developed fog nets and dew collectors thousands of years ago, physical structures that cooled air through the night and collected the condensate in the morning. The technology works, it just did not scale. Modern AWG systems apply electricity to the same principle, using refrigeration coils to actively cool large volumes of air below the dew point, collecting and filtering the resulting condensate. Commercial AWG units have existed for decades. The fundamental challenge they have faced is energy efficiency. The amount of electricity required to cool sufficient air to produce meaningful quantities of water has historically made large-scale AWG economically unviable compared to conventional water supply systems. The DripDrop breakthrough, a 4-part proprietary system. DripDrop USA's breakthrough is a proprietary 4-part system that addresses the energy efficiency problem from a completely different engineering direction, and in doing so, unlocks the ability to produce not just liters or hundreds of gallons, but millions of gallons of pure water per day from atmospheric vapor. The company describes its technology as capable of supplying water to an entire metropolitan area from a single installation. While DripDrop USA protects the specific engineering details of its proprietary process as trade secrets, the 4-part architecture draws on an integrated approach to air handling, heat exchange, condensation optimization, and water purification that achieves dramatically higher water yield per unit of energy input than conventional AWG designs. The system is specifically optimized for hot and arid environments, precisely the conditions found in most of the world's water-scarce regions, including the cities of India, the Middle East, North Africa, and the American Southwest. Stage 1. High-volume air capture and preparation. The system begins with large-scale intake and conditioning of ambient air, drawing in the maximum possible volume and preparing it for efficient water extraction. The design of this stage determines the throughput ceiling of the entire system, and DripDrop USA's proprietary intake architecture is engineered for metropolitan-scale water production volumes. Stage 2. Thermodynamic condensation at optimized efficiency. The core water extraction stage applies thermodynamic cooling through a heat exchange system engineered for maximum water yield per kilowatt-hour of energy input. This is where DripDrop's fundamental efficiency advantage resides, the ability to extract significantly more water from the same volume of air at the same ambient humidity level than competing AWG systems. In hot and arid environments where conventional AWG struggles to be economical, DripDrop's optimized condensation stage produces viable yields. Stage 3. Collection and primary filtration. Condensed water is collected and passed through primary filtration systems that remove particulates and prepare the water for the purification stage. Unlike water drawn from rivers, lakes, or aquifers, which carries dissolved minerals, agricultural runoff, industrial contaminants, heavy metals, and biological organisms accumulated across the entire watershed, atmospheric condensate begins as pure water vapor, free of the dissolved solids and contaminants that define ground and surface water quality problems worldwide. Stage 4, purification and quality assurance. The final stage delivers water that is free of sodium chloride, boron, alkali, chloride, and the full range of chemical and biological contaminants that render conventional water sources unsafe without extensive treatment. DripDrop water is non-mineralized, meaning it can be remineralized to any desired specification for human consumption, agricultural irrigation, or industrial process use. It contains no pollutant discharge, no toxic byproducts, and requires none of the brine disposal that makes desalination environmentally problematic. The result is water production that is environmentally clean from source to delivery, infinitely scalable by adding system capacity, and entirely independent of rainfall, river flow, aquifer levels, or any other ground or surface water source. As long as there is air, which is to say as long as there is an atmosphere, DripDrop can produce water. DripDrop water begins as pure vapor. It contains none of the dissolved contaminants that make conventional water treatment necessary, none of the brine waste that makes desalination environmentally damaging, and none of the regulatory dependencies that make conventional water supply uncertain. It is water created where it is needed, from the air above the city, that will consume it. Part 2. The Global Water Emergency. Why this technology is urgent. The scale of the global water crisis is difficult to communicate in terms that convey its true severity, because water scarcity is experienced locally and personally in ways that aggregate statistics obscure. So consider it city by city. Cairo, Egypt, population 20.9 million people, consumes 300 billion gallons of water annually, drawn primarily from the Nile River. The Nile's flow is declining as upstream dam construction, agricultural extraction, and climate-driven rainfall reduction all reduce the volume reaching Egypt. Egypt is already below the United Nations threshold for water poverty, defined as less than 1,000 cubic meters per person per year, and the trajectory is worsening. Istanbul, Turkey, population 15.2 million, draws on reservoirs that fell to less than 30% capacity during the 2020 to 2021 drought, prompting the Turkish government to warn of potential water rationing for the first time in the city's modern history. Istanbul uses 270 billion gallons annually from a catchment system that climate models project will receive 20 to 30% less rainfall by 2050. Riyadh, Saudi Arabia, population 7.2 million, consuming 217 billion gallons annually, sits in a desert with virtually no surface water and depends primarily on desalination and rapidly depleting fossil aquifers for its water supply. The fossil aquifers beneath Saudi Arabia, which took thousands of years to accumulate, are projected to be exhausted within decades at current extraction rates. Calcutta, India, 15 million people, 200 billion gallons annually. Madras, India, 11 million people, 160 billion gallons annually. These are the cities of the country where HYDC is building its smart city portfolio, and Bengaluru, not on this list only because the data is more recent, has been rated by researchers at the Indian Institute of Science as one of the fastest depleting groundwater cities in the world, with extraction rates 4 times the natural recharge rate. Rio de Janeiro, Brazil. Phoenix, Arizona, Cape Town, South Africa, Lima, Peru. Each of these cities represents a massive, growing, urgent market for water supply technology that is independent of rainfall, independent of rivers, independent of aquifers, and independent of the political and infrastructure complications of conventional water supply. Every one of them is a potential DripDrop installation site. Every one of them is a potential Citiwerx franchise location, and every one of them is a city where the ability to generate water from air is not a luxury or an innovation showcase. It is a survival necessity. The Indian context, where the crisis meets the opportunity. India's water crisis is the most acute dimension of the global emergency, and it is the most directly relevant to the Citiwerx program. India is home to 18% of the world's population, but holds only 4% of its freshwater resources. Groundwater provides 60% of India's irrigation and 85% of its rural drinking water. And India extracts more groundwater than any other country on Earth, accounting for roughly 25% of total global groundwater withdrawal. The consequence is predictable and already visible. Water tables across India's agricultural heartland are falling by 1 to 3 meters per year. Cities built on the assumption of reliable groundwater are experiencing supply failures they were not designed to manage. The Indian government's own Niti Aayog report concluded that 21 major Indian cities, including Delhi, Bengaluru, Chennai, and Hyderabad, are facing groundwater depletion that could reach critical levels by 2030. For a smart city program targeting India's fastest-growing urban centers, water supply is not a peripheral infrastructure consideration. It is an existential strategic question. A Citiwerx township that cannot guarantee its water supply cannot guarantee the quality of life it promises its residents. A township that draws on declining regional aquifers is building its premium value proposition on a foundation that is literally sinking. DripDrop's atmospheric water generation technology eliminates this vulnerability entirely. A Citiwerx township equipped with DripDrop AWG infrastructure does not depend on regional aquifers. It does not depend on municipal water supply systems. It does not depend on rainfall or river flow or any hydrological variable outside its control. It generates its water from the air above it, air that is present in sufficient quantity everywhere on Earth, at every elevation, in every climate, at every season of the year. India extracts more groundwater than any other country on Earth. The aquifers beneath Bengaluru are declining at 4 times the natural recharge rate. A Citiwerx township that generates its own water from atmospheric vapor is not just convenient. It is the only water strategy that is genuinely future-proof. Part 3. Where Turbogen meets DripDrop, the energy-water nexus. Energy and water are inseparable. Every water supply system consumes energy to pump, to treat, to distribute, to heat, to recycle. And the DripDrop AWG system, for all its elegance and efficiency, requires a significant and continuous supply of electrical power to operate the air handling, refrigeration, and purification systems that produce water at metropolitan scale. This is where the Turbogen microgrid and DripDrop AWG converge, not as independent technologies sharing a geography, but as complementary systems whose strengths precisely address each other's requirements. Recall what the Turbogen microgrid delivers: a distributed power generation system based on hypersonic pulse combustion technology, achieving base thermal efficiency far above conventional generators, rising to 85 to 90% total efficiency through cogeneration. The simultaneous extraction of electrical power and useful thermal energy from the same combustion event. A system with only one moving part, fuel-agnostic design capable of running on biogas from the township's own organic waste, and a closed-loop circular energy architecture in which the city's waste becomes its fuel generates its power, and its power runs its systems. Now consider what DripDrop requires: continuous, reliable, cost-effective electrical power to drive its atmospheric condensation process. In a grid-dependent scenario, DripDrop's operating economics are directly tied to the cost and reliability of grid electricity, a dependency that is problematic in India's strained grid environment. In a scenario where DripDrop is powered by a Turbogen microgrid running on locally produced biogas, that dependency dissolves entirely. The cogeneration advantage. Thermal energy for water production. The connection runs deeper than a simple power supply. The Turbogen's cogeneration thermal output, the captured exhaust heat that, in a residential microgrid application, heats water and supports space conditioning, has a direct and valuable application in the DripDrop water production process. Atmospheric water generation efficiency is a function of the temperature differential achieved between the incoming air and the condensation surface. The greater the differential, the more water is extracted from a given volume of air. The turbogen's thermal output can be integrated into the DripDrop system's heat exchange architecture, providing supplemental thermal energy that enhances the condensation differential without additional fuel consumption. The cogeneration heat that would otherwise be used only for residential hot water and space heating becomes, in the integrated system, a water production multiplier, the same British thermal unit serving double duty, first in the thermal energy system and again in the water generation system. The economics of this integration are compelling. The turbogen is already generating thermal output as a byproduct of electrical generation. Using that thermal output to enhance DripDrop water production adds water yield without adding fuel cost. The marginal cost of the additional water is essentially zero, a byproduct of a byproduct extracted at no additional energy input. The biogas connection. Water produces, energy produces water. The circular economy architecture of the Citiwerx township creates a further connection between the water and energy systems that is almost elegantly self-referential. The township's organic waste, from residences, restaurants, vertical farms, and the DripDrop water production process itself, feeds anaerobic digesters that produce biogas. That biogas fuels the turbogen. The turbogen generates electricity and thermal output. The electricity powers the DripDrop system. The DripDrop system produces water. The water supports the vertical farms. The vertical farms produce organic waste. The waste goes back to the digesters. And the anaerobic digestion process itself requires water, both as a feedstock for the digester and as a process medium for the biological activity that produces methane. DripDrop produced water, free of the dissolved minerals and contaminants that can inhibit anaerobic microbial activity, is ideal for this application. The water system feeds the energy system. The energy system powers the water system. Both systems are fed by the city's waste streams. The city's resource flows are circular, closed, and self-reinforcing at every point. Turbogen powers DripDrop. DripDrop waters the vertical farms. The vertical farms produce waste. The waste fuels the turbogen. This is not a supply chain. It is a cycle. A city that consumes its own outputs and wastes nothing. Part 4. Where iLamp meets DripDrop. Intelligence for the water system. If turbogen is the energy engine that powers DripDrop, then iLamp is the nervous system that makes the entire water infrastructure intelligent. The iLamp network deployed throughout a Citiwerx township provides, among its many capabilities, continuous environmental sensing, air quality, temperature, humidity, atmospheric pressure, particulate levels, and weather conditions at street-level density across every part of the city. For a DripDrop atmospheric water generation system, this sensor network is not merely useful. It is operationally transformative. Real-time humidity intelligence, optimizing every cubic meter of air. The efficiency of any atmospheric water generation system is directly dependent on ambient humidity. Higher humidity means more water vapor per cubic meter of air, more condensate per unit of energy expended, and more water produced per operating hour. Lower humidity means the system must process more air to produce the same water yield, consuming more energy per liter of output. The iLamp environmental sensor network provides real-time humidity data at street-level resolution across the entire township. Not one reading from one weather station, but hundreds of readings from hundreds of poles, painting a continuous, dynamic humidity map of the city's entire atmosphere. The Citiwerx digital platform ingests this data and feeds it to the DripDrop system's operational management software, which uses it to continuously optimize intake volume, refrigeration intensity, and processing throughput based on actual real-time atmospheric conditions rather than fixed operational schedules. When a weather system brings increased humidity to the township, a pre-monsoon atmospheric moisture surge, a weather front, elevated humidity following rainfall elsewhere in the region, the DripDrop system ramps up production to capture the atmospheric bounty. When conditions are drier, the system modulates its operation to maintain production efficiency. The intelligence layer transforms the water generation system from a static industrial process into a responsive, optimizing organism that works with atmospheric conditions rather than despite them. Air quality data, protecting water purity at the source. The iLamp network's air quality monitoring capability provides a second critical input to the DripDrop water system: continuous real-time data on atmospheric particulates, chemical contaminants, and pollution events that could affect the quality of water produced from the ambient air. Atmospheric water condensed during a pollution event, a nearby industrial emission, a dust storm, a wildfire smoke incursion, will carry suspended particulates and chemical contaminants into the collection system. Without real-time air quality awareness, the DripDrop system's filtration and purification stages must be sized to handle worst-case contamination continuously, adding cost and complexity. With the iLamp air quality data stream integrated into the DripDrop operational management system, the purification response can be calibrated dynamically, intensifying filtration and purification when air quality degrades, modulating back to standard operation when conditions clear. In the most extreme pollution events, the system can be programmed to pause intake and draw on storage reserves until air quality returns to acceptable parameters, a response that protects water purity without requiring manual intervention, triggered automatically by the iLamp sensor network detecting the contamination event in real time. Weather forecasting, the predictive advantage. The iLamp weather station network, aggregating temperature, humidity, pressure, wind speed and direction, and precipitation data from hundreds of units across the township and its surroundings, becomes a hyper-local weather forecasting platform when its data is fed to the Citiwerx analytics engine. For the DripDrop water system, this predictive capability means the ability to anticipate atmospheric conditions hours or days in advance and pre-position production accordingly. If the analytics engine forecasts a 3-day dry period with declining humidity, the DripDrop system can run at elevated production during the preceding high humidity window, filling storage capacity and buffering against the anticipated production reduction. If a high humidity weather event is forecast to arrive in 12 hours, the system can prepare its processing capacity to maximize yield capture during the atmospheric window. The water system becomes proactive rather than reactive, a fundamental operational advantage that is enabled entirely by the intelligence infrastructure that iLamp provides at no additional cost to the water operation. iLamp gives the DripDrop water system eyes, ears, and foresight. The water system knows the humidity of every street, the air quality of every block, and the weather of the next 3 days, and it uses that knowledge to produce more water of higher quality at lower cost per gallon than any atmospheric water system operating without that intelligence layer. Part 5. DripDrop inside Citiwerx. 5 applications. With the TurboGen providing power, iLamp providing intelligence, and the Citiwerx digital platform providing the management architecture, DripDrop. AWG technology integrates into the Citiwerx smart city ecosystem across 5 distinct and mutually reinforcing applications. Application 1. Residential water supply, complete grid independence. The most fundamental application of DripDrop AWG in a Citiwerx township is residential water supply. Every home, every apartment, every commercial unit in the township requires reliable, clean, safe water for drinking, cooking, bathing, sanitation, and household use. A Citiwerx township equipped with DripDrop AWG infrastructure produces its entire residential water supply from atmospheric vapor, with no connection to the regional municipal water system required. The township is water sovereign from day one, in the same way that a turbogen microgrid makes it energy sovereign. Residents receive water that is demonstrably purer than municipal supply, free of the dissolved minerals, agricultural runoff, pharmaceutical residues, and aging pipe contamination that characterize urban water systems across India and the developing world. They receive it reliably, regardless of what the regional water supply system is doing. And the township's water supply is never subject to municipal rationing, infrastructure failures, or the political and administrative delays that characterize public utility management. For the residents of a Citiwerx township, technology professionals, business owners, and families who are choosing to pay premium prices for premium quality of life, water sovereignty is not a minor amenity. It is a fundamental component of the value proposition that makes Citiwerx worth its premium over the surrounding market. Application 2. Vertical farm irrigation, precision agriculture water supply. Citiwerx townships incorporate vertical farming as a core food supply and sustainability infrastructure component. Vertical farms, indoor growing facilities using controlled environment agriculture, LED lighting, hydroponic or aeroponic growing systems, and precise nutrient delivery, produce fresh vegetables, herbs, and fruits at yields per square meter that far exceed conventional field agriculture, with 95% less water consumption than field irrigation. That 95% water use efficiency advantage over conventional agriculture is, however, contingent on the quality of the water used. Hydroponic and aeroponic growing systems are sensitive to dissolved mineral content, pH, and chemical contamination in their water supply in ways that field soil agriculture is not. Hard water with high mineral content can clog nutrient delivery systems, alter pH balance, and produce inconsistent growing conditions. Chemically contaminated water can accumulate in plant tissue, producing food safety concerns that compromise the township's food supply program. DripDrop atmospheric water, non-mineralized, contaminant-free, and chemically consistent by nature, is the ideal irrigation water source for vertical farm operations. Its chemical neutrality means that nutrient delivery can be precisely controlled without compensation for variable mineral background levels. Its consistency means that growing conditions remain stable and reproducible. And its purity means that food safety concerns from water contamination are eliminated at the source. The integration is elegant. Turbogen powers the vertical farm's lighting and climate control. iLamp monitors the farm's environmental conditions and reports to the Citiwerx platform. DripDrop supplies the precision water that the hydroponic systems require. The three technologies work together to create a food production system that is simultaneously more productive, more reliable, and more sustainable than any conventional agriculture alternative. Application 3. Water treatment process support. Citiwerx townships incorporate closed-loop water management systems that treat and recycle gray water and process water for non-potable applications, toilet flushing, cooling water, landscape irrigation, and industrial process use. These treatment systems achieve 20 to 40% efficiency gains over conventional open-loop water management, dramatically reducing the net water consumption of the township. DripDrop AWG plays a dual role in this closed-loop system. First, it provides the high-purity feed water that many water treatment processes require, processed water that must meet strict chemical specifications to prevent scaling, corrosion, and biological fouling of treatment membranes and equipment. Second, it provides a quality benchmark for the treated water stream. The DripDrop system's output can be blended with treated recycled water to achieve the precise quality specifications required for each end use, without the overtreatment cost of purifying all recycled water to potable standard. The result is a water management system that is simultaneously more efficient, more resilient, and more economical than either conventional supply or standalone treatment could achieve independently. Every liter of water that enters the Citiwerx township water cycle is used, recycled, and reused to the maximum extent possible, with DripDrop AWG providing the quality top-up and reserve capacity that keeps the entire system operating at specification. Application 4. Emergency and Resilience Reserve. The same off-grid resilience that makes turbogen and iLamp valuable in disaster scenarios applies with equal force to DripDrop water supply. When a regional water crisis occurs, a contamination event, a supply infrastructure failure, a prolonged drought that empties the municipal reservoirs, conventional urban water supply fails. Residents scramble for bottled water. Hospitals and essential services operate under water rationing. The economic and social disruption is severe. A Citiwerx township with DripDrop AWG infrastructure continues producing water normally. The atmospheric moisture that is the system's feedstock is unaffected by whatever ground or surface water emergency is affecting the region. The township's residents, businesses, medical facilities, and vertical farms continue receiving water at normal quality and flow rates. The township becomes a resilience anchor, not just for its own residents, but potentially as a water supply resource for the surrounding community during an emergency. This resilience value is particularly significant in the Indian context, where climate change is projected to increase the frequency and severity of both drought and flood events simultaneously, a paradoxical combination driven by more intense monsoons delivering more rain in shorter periods to soil that can no longer absorb it, followed by longer dry seasons with less recharge of the aquifers that failed to refill during the truncated wet season. A water system that is independent of both rainfall and groundwater is not merely resilient. It is the only water system architecture that remains viable under these projected conditions. Application 5. The water revenue stream, DripDrop as a HYDC profit center. Here is the dimension of the DripDrop integration that transforms it from an infrastructure cost into a revenue-generating asset for HYDC and its investors, and it is perhaps the most compelling aspect of the entire proposition. A Citiwerx township that produces water in excess of its internal consumption requirements has a product of extraordinary value that it can sell to the surrounding community, to regional water authorities, to agricultural users, and to industrial operations. In a water-scarce market, and Bengaluru, Delhi, Mumbai, and every other Citiwerx target city qualifies, the ability to supply pure, reliable, contaminant-free water at scale is a commercial franchise of significant value. Consider the market context. Bottled water in India is a market exceeding 250 billion rupees annually and growing at over 20% per year, driven by urban consumers who no longer trust tap water quality. Municipal water tariffs in Indian cities have been rising steadily as supply constraints tighten and infrastructure costs increase. Industrial water users, data centers, pharmaceutical manufacturers, food processing facilities, semiconductor fabrication plants pay premium prices for high-purity processed water. Agricultural operations facing irrigation water restrictions would pay competitive rates for a reliable, regulated water supply that allowed them to maintain production. A Citiwerx township operating a DripDrop, a WG system sized for metropolitan-scale production, is positioned to capture value across every one of these market segments simultaneously. Residential water supply within the township, included in resident service fees, contributing to the township's revenue base. Premium bottled and bulk water sales to the surrounding community, a branded, verified pure water product with a compelling origin story. Industrial process water supply to commercial tenants and neighboring businesses. Agricultural irrigation water supply to farming operations in the township's surrounding region. The water revenue stream is independent of the township's residential occupancy. It is independent of the real estate market cycle. It is a utility franchise backed by a physical production system that generates value every hour it operates, regardless of economic conditions, market sentiment, or investor appetite. In the language of HYDC's investment thesis, it is recurring, infrastructure-backed, crisis-resistant revenue, exactly the kind of cash flow that institutional investors and sovereign wealth funds find most attractive. Water is the only commodity for which there is no substitute, no alternative, and no reduction in demand. A Citiwerx township that produces surplus water in a water-scarce market does not have a cost center. It has a utility franchise. Part 6. The Integrated System: Energy, Intelligence, Water, and Food. Step back now and consider what the full integration of Turbogen, iLamp, and DripDrop AWG inside the Citiwerx platform actually creates. Not three separate technologies sharing a geography. A single, integrated, self-reinforcing urban resource system in which every component strengthens every other component, and the whole is dramatically more valuable than the sum of its parts. Turbogen generates electricity and thermal energy from biogas produced by the township's organic waste. The electricity powers everything: homes, businesses, vertical farms, the DripDrop water system, the iLamp network, the Citiwerx digital platform. The thermal output supports the DripDrop condensation process, the vertical farm climate control, and residential hot water. The biogas feedstock comes from the township's own waste streams: organic kitchen waste, agricultural residues from the vertical farms, and the biological outputs of the water treatment system. iLamp provides the intelligence layer: continuous environmental sensing at street-level density, 5G communications infrastructure, AI-powered traffic and safety management, edge computing capacity sold to global AI workloads for revenue, and the real-time atmospheric data that makes the DripDrop water system operate at maximum efficiency. Every iLamp pole is simultaneously a street light, a safety monitor, a weather station, a communications hub, and an AI compute node earning money around the clock. DripDrop AWG produces the water the township needs for residents, for vertical farms, for water treatment processes, for cooling, for sanitation, and for sale to the surrounding community. Its production is powered by Turbogen electricity, enhanced by Turbogen thermal output, and optimized by iLamp atmospheric intelligence. Its output feeds the vertical farms, supports the anaerobic digesters, and provides the township's water sovereignty, independence from regional supply systems that are themselves under existential stress. The vertical farms, powered by Turbogen and irrigated by DripDrop, produce fresh food for the township's residents. Their organic waste goes to the anaerobic digesters. Their growing environment data is monitored by the iLamp sensor network. Their produce is managed and distributed through the Citiwerx digital platform. The Citiwerx digital platform, the 7-layer IoT architecture that connects every building, every utility, every sensor, and every resident service in the township, orchestrates all of it. It routes power, it manages water production and distribution, it monitors air quality and weather, it optimizes traffic, it processes the data streams from hundreds of iLamp units and feeds intelligence back to every system in the city. It delivers resident-facing services, energy dashboards, water quality reports, air quality readings, food ordering, community services, safety alerts. And the Citiwerx digital platform market, estimated to reach $500 billion by 2026 and $1 trillion by 2032, generates the digital economy revenue that sits on top of all of this physical infrastructure, providing the commercial layer that turns the township's integrated resource sovereignty into a scalable, franchisable business model. This is the Citiwerx Smart City fully realized. Not a housing development with some smart technology bolted on. A complete urban ecosystem in which energy, intelligence, water, food, and digital services are all generated internally, all managed intelligently, all connected to each other in a circular resource economy that produces more value with less waste as it grows. Energy sovereignty, intelligence sovereignty, water sovereignty, food sovereignty, digital sovereignty. 5 forms of independence, 5 revenue streams, and 5 competitive advantages, all derived from 3 technology integrations inside a single city platform. This is what Citiwerx becomes when Turbogen, iLamp, and DripDrop are all present. Part 7. The Revenue Stack. Water as a HYDC business. Let us be precise about the commercial opportunity that DripDrop AWG represents for Huntington York Development Corporation as an independent revenue stream, separate from and additive to the township development business. HYDC's 8-city Indian deployment targets 130,000 homes across the major metropolitan centers of Bengaluru, Delhi, Mumbai, Pune, Hyderabad, Chennai, Ahmedabad, and Kolkata, cities that together represent the core of India's water-stressed geography. Every one of these cities is operating under conditions of water scarcity that will worsen, not improve, over the investment horizon of the Citiwerx program. The demand for reliable, high-quality water supply in these cities is not a market to be developed. It exists now, it is growing rapidly, and it is insufficiently served by any existing supply technology. A DripDrop, a WG installation sized for metropolitan-scale production, producing millions of gallons per day, represents infrastructure with a replacement cost value measured in tens of millions of dollars. The water it produces has a market value in multiple concurrent channels: residential supply, premium bottled water, industrial process water, and agricultural irrigation supply. The economics of atmospheric water generation improve with scale. The fixed capital costs of the intake, condensation, collection, and purification infrastructure are spread across a larger production volume as system capacity increases. The marginal cost of producing an additional gallon declines as the system approaches its design throughput, and with Turbogen providing the electrical power at higher efficiency and lower fuel cost than grid electricity, and with Turbogen's thermal output enhancing condensation efficiency at no additional cost, the operating economics of a Citiwerx integrated DripDrop system are superior to any standalone AWG installation. For HYDC investors, the water revenue stream from DripDrop AWG has the characteristics that institutional capital finds most attractive: infrastructure-backed, demand-inelastic, recession-resistant, and index-linked to the growing scarcity of the resource being produced. As India's water crisis deepens, and all hydrological evidence indicates that it will, the value of water production infrastructure in India's major cities increases. The assets appreciate precisely because the problem they solve worsens. This is not speculation on future technology adoption. It is investment in the infrastructure solution to a crisis that is already here. The franchise multiplier: water revenue at global scale. The Citiwerx franchise model, designed for deployment across India's 104 Tier 2 cities and then globally, carries the DripDrop AWG system as a core infrastructure component of every township, in the same way it carries the Turbogen microgrid and the iLamp intelligence network. Every franchise deployment is another DripDrop water system installed in a water-scarce market. Every deployment adds another revenue stream to the Citiwerx franchise economic model. Every proof of concept in one city strengthens the commercial case for the next. Beyond India, the global addressable market for atmospheric water generation is defined by the geography of water scarcity, which is to say, it encompasses most of the world's fastest-growing cities. The Middle East, where water scarcity is already driving geopolitical instability. Sub-Saharan Africa, where 600 million people lack reliable access to clean water. The American Southwest, where the Colorado River Compact is collapsing and major cities face supply constraints not seen since the region was first settled. Southeast Asia, where rapid urbanization is outpacing water infrastructure investment in dozens of major cities. DripDrop USA's mission to become the global leader in the atmospheric drinking water devices market aligns precisely with HYDC's global franchise ambition. Every Citiwerx township is a DripDrop deployment. Every DripDrop deployment is a Citiwerx competitive advantage. The two business models scale together, reinforce each other, and compound in value as each new city is built and each new franchise is awarded. The global market for water supply technology is not defined by willingness to pay. It is defined by physical necessity. Every city where the aquifers are declining, every city where the rivers are shrinking, every city where the municipal system is failing, every one of these is a market for DripDrop water, and every one of them is a potential Citiwerx franchise location. Epilogue: the city that makes its own water. There is a thought experiment that engineers and city planners use when designing critical infrastructure. What happens if the supply chain fails? What happens if the power goes out, the water stops flowing, the food supply is disrupted? How long can the city survive? For most of the world's cities, the honest answer to all three questions is not long. Most cities have days of water storage, weeks of food inventory in the supply chain, and no meaningful energy independence. They are dependent nodes in fragile networks that extend hundreds or thousands of miles in every direction. Networks that have worked reliably for long enough that we have forgotten they are fragile. The Citiwerx Smart City, fully equipped with turbogen microgrid energy, iLamp intelligence infrastructure, and DripDrop atmospheric water generation, has a different answer to that thought experiment. The energy comes from the air, the waste, and the sun. The intelligence comes from the city's own sensor network. The water comes from the air above the city. The food comes from the vertical farms inside the city. The digital economy comes from the platform that connects all of it. This city does not run dry when the aquifers fail. It does not go dark when the grid goes down. It does not lose connectivity when the telecommunications infrastructure is stressed. It does not run out of food when the supply chain is disrupted. It is resilient at the level of its fundamental systems, not because it has bigger reserves of externally supplied resources, but because it generates its own. DripDrop USA CEO Jesse Flores and his team understood something fundamental when they designed the atmospheric water generation system around the principle of extracting water from the air. The atmosphere is the most universally distributed, most consistently available, most democratically accessible water source on Earth. It does not belong to any country, any corporation, or any government. It is present above every city, every farm, every desert, every slum. It has been there throughout the entire history of human civilization, silently holding more fresh water than all the world's rivers and lakes combined, waiting for someone to build a machine that could harvest it reliably, efficiently, and at the scale that cities require. DripDrop has built that machine. Turbogen has built the engine to power it. iLamp has built the intelligence to optimize it. And Citiwerx has built the city to house all three, and to demonstrate for the first time in the history of urban development that a city designed with genuine resource sovereignty is not just more sustainable than a conventional city. It is more livable, more resilient, more valuable, and more profitable. The city that makes its own water, powers its own grid, sees its own streets, grows its own food, manages its own digital economy, and earns revenue from all of it, every hour of every day, regardless of what is happening to the infrastructure beyond its borders. That city is a Citiwerx Smart City, and it is being built today.